Welcome to my channel. My name is Opubo. For those of you new to the channel, I bid you welcome. And for those of you returning, I bid you welcome back. Good to have you back. You're all well appreciated. As usual, in this channel, I present various ideas and designs of technologies, mostly from the Technology IP Bank of Enhanced Knowledge LLC, often integrated from several other technologies of the IP Bank and made ready for adoption by the Adoption Brokerage Division. This presentation focuses on GGS carboxylic acid process technology to the extent that it has a role to play in fostering and enabling conservation economy. The technology specifically focuses on the production of carboxylic acid out of the greenhouse gases of carbon dioxide as fundamental approach to addressing issues of food and health as impacted by climate change towards enabling a conservation economy from the technological perspective, and the approaches a community or region or even a nation would adopt to ensure the sustaining of a conservation economy by the use of this technology. Of course, an apt and acceptable contributory resolution obtains from the production of carboxylic acid in the sense that climate change is said to impact food production, and so utilizing the causes to countermand the consequences is just common sense rational. The chemistry, of course, is required to be also necessarily in conformance with the national thinking of the prevailing civilization and as defined by the civilizational underpinning science. Digressing for a moment, if you have not as yet subscribed to the channel, I implore you to do so. Please click the subscribe button now. Go ahead and subscribe by simply clicking on the subscribe button below. The subscription would cause the system to keep you informed by notification of the next presentation the moment one is published, and also, of course, help me to more consistently continue to elicit the peace dividend of conservation economy. Now, back to the presentation. Carbon dioxide as a resource for enabling conservation economy has been extensively presented in the several videos that have been provided so far. Subsequently, the utilization of the carbon dioxide as resource has been presented with respect to its use in the production of energy fuels such as ethanol and butanol, both of which enable, of course, conservation economy. Yet, the availability or lack thereof of food in societies has determined numerous societal issues such as migration and the consequential political issues in nations, effectively being a major issue of contention and has been an underlying factor in numerous conflicts. Carboxylic acid being a key ingredient, reactant in the production of amino acids, which is subsequently used by live cells to produce proteins, clearly contributes to the health and wellness considerations of the conservation economy, and its being produced with carbon dioxide proffers yet a means of sequestration from the larger ambience. Yet, the utilization of greenhouse gases to produce carboxylic acid, while rational, may be argued by some as not entirely beneficial to humanity. The industrial scale extraction of carbon dioxide required for the purposes of chemical production has given some people concerns. But the utilization for carboxylic acid directly affecting the health and wellness of humanity, it would seem, has greater weighting. Moreover, in the event that there is a situation as climate change or global warming as confessed by some people, and the sequestration of the greenhouse gases is important, then the utilization of carbon dioxide component as consumable by human is far more of a secure approach than any other approach of sequestration. On the other hand, if there is no such situation as contested by others, then the utilization of carbon dioxide as a helpful consumable stands to significantly improve the wellness of humanity. In either outcome of the matter of global warming or climate change, humanity comes out a winner from the utilization of carbon dioxide to produce carboxylic acid as consequence of any prevailing conservation economy. The technology designed for the production of the carboxylic acid integrates from the technology IP bank and is as shown in the figure. Conceptually, hydrogen gas and carbon dioxide are fed into the technology, which ignites a reaction between the gases, causing a structured composition reaction. And in this particular case, the industrial process chemistry of the composition reaction is as given by the congealed or stoichiometric formula that you see here. Hydrogen and carbon dioxide produces carboxylic acid. Very simple and straightforward. And judging by this reaction formula, given the simplicity, the issue of global warming or climate change can be said to be significantly mitigated with this helpful sequestration of carbon dioxide in the form of carboxylic acid. By design, the technology consists of a thermosiphon reboiler, electrolyzer, programmable chemical reactor model 3G, a cooler condenser, and 2 storage tanks for carbon dioxide and the carboxylic acid. The thermosiphon reboiler and the electrolyzers are the 2 equipments to the left. They are the 2 leftmost equipment. The programmable chemical reactor model 3G and the cooler condenser are pretty much in the middle. They are the 2 middle equipment. And the storage tanks are the equipment to the extreme right. During operation, water is pumped into the thermosiphon reboiler, which boils the water into hot steam, that then is pumped into the electrolyzer, that dissociates the steam into hydrogen and oxygen. And the oxygen then flows into its storage tank, not shown, while the hydrogen flows into the programmable chemical reactor at the base pot made specifically for that. Simultaneously, carbon dioxide is pumped into the programmable chemical reactor just below the feed pot of the hydrogen on the same base section of the reactor, which ignites the reactions and converges ultimately into a composition reaction. The carboxylic acid, being short chain, is a liquid in vapor state and is carried out into the cooler condenser that condenses the carboxylic acid into liquid, while the excess carbon dioxide flows into the storage tank for recycle back to the reactor. The liquid carboxylic acid gets pumped into the designated storage tank. Of particular note is the use of the plural in the nomenclature of the acid, carboxylic acids, when in fact the product of the chemistry as provided is just formic acid, just one form of the family of acids. The justification for the use of the plural sense is based on the recognition that with the use of various models of the programmable chemical reactors, it is trivial to produce longer carbon chain carboxylic acids by reacting ethenes, propenes, butenes with the formic acid itself. Hence the use of the plural carboxylic acids. Another variant controlled use yet of the programmable chemical reactors enables the production of longer carbon chain carboxylic acid by reacting long chain hydrocarbons with the formic acid. Such long chain hydrocarbon, of course, can also be produced with one of the programmable reactors by polymerization of methane. Granting the programmable chemical reactor's functionality, though proprietary. On the strength of the chemical science of the presentation, therefore, there can be uniform acceptance that, in fact, there is a conservation economy technology that provisions carboxylic acid, which is produced by the utilization of carbon dioxide, that can be utilized yet in every other conservation economy technology that requires carboxylic acid. The materials of construction being mainly steel, the technology is well suited for the utilization of discarded metal parts in every region, allowing for the elimination of discarded process equipment that would otherwise be branded as waste. So, under the requirements of conservation economy, this technology enables the existence of such economy. Now then, if interested in licensing this technology, please send an email to me. The email address is put in the pinned link below, as are other useful information. Regarding licensing consideration, there are some notes that should be of interest. Worthy of note is that while the process as presented displays only one of each type of process equipment, the actual industrial adoption may require more than one, as required by the production volume specification. And this is significant because the technology licensing agreement generally is based on a per equipment and then aggregated before the functionality clause is added. Further, the industrial scale production of carbon dioxide also requires that the licensing of this technology be considered to be taken together with the co-licensing of one of the carbon capture technologies presented in earlier videos. The links to them are written in the pinned comment section below as well. That said, I wrap up the presentation by saying to you, thank you for being here, and I appreciate your coming to listen and viewing the presentation. And if you have not subscribed as yet, do please subscribe to the channel now. Meanwhile, I do hope and expect that you would consider coming back for the rest of the future presentations of the varied technologies. The fact is, even if you do not adopt the technologies, some just might change your perspective of society and life. Until the next presentation, I wish you be well.